Hello guys, so let us begin with our next assignment, that is decision tree classifier. Okay, so in this assignment they have given us the data which we have to manually uh, feed into a CSV file, and we have to create the data set on our own. Okay, because they haven't provided us with a data file. Okay, so due to that we have to create a CSV file for it. So as our assignment says, we have to use decision tree classifier to classify this particular data set, and the attributes in it are the age, income, gender, and marital status. And based on these features, we are gonna predict the bias feature for each and every data point. So basically, what these four features are, I mean the age, income, gender, and marital status, these are the independent features, okay, independent variables. And bias column is nothing but a dependent value or dependent variable. Why? Because uh, based on these four features, the age, income, gender, and marital status, based on these four features, we will be able to predict whether a person buys that product or not. So in our case, it is a cosmetic product. Okay, and once we train our model with the help of this data, we have to predict whether or not a person with these features, the age is less than 21, income equal to low, gender is female, marital status is married. The person having these features will buy the product or not. So it will be yes or no. Okay. So now let us quickly look into what is a decision tree and how does it look like. Okay. So I hope you guys are aware of a binary tree. So, decision tree is the structure of decision tree is similar to somewhat we can say it's like a binary tree. Okay, so it has a root node, and each node has two child nodes. So basically, the first one is the root node, and these all nodes are the intermediate nodes, and the bottom are the leaf nodes. Okay, so the leaf nodes consist of the actual prediction or the desired value or the class of our prediction. So this is basically the output. Okay, so now what is a decision tree? So first of all, a decision tree is nothing but a classifier. We can that means we can use it for classification purpose, and also decision tree can be used for regression as well. Okay, but as far as our assignment is concerned, we will be using that algorithm for classification purpose only. Okay, so the first node, let us consider this node, the first node. So it can be termed as a decision node as well. Why? Because on each node we have to make a decision, or let's say a question is asked on each node, and the answer to the question is either yes or no, or the answer to the question can be split into two like two possibilities. Okay, so let's take an example. Let's say if we fire a question at this particular node, at the very first node, that the age is less than 21 or not. So the answer to that question will be yes or no. Okay, so similarly over this particular node, if we ask another question, let's say uh, what is the gender of that particular person, so it will be again male or a female. Okay, so see, the question has only two answers. So that's why that is how we are able to form this binary tree like structure. Okay, so this is it. So this is a decision tree classifier algorithm. Okay, and again two more things that come into picture are entropy and information gain. So whenever we discuss about decision tree, we come across these two terminologies. So you might have studied it into your theoretical part, but let me quickly define it for you. So what is an entropy? And what it basically does is it controls how a decision tree decides to split the data. Okay, so it actually decides how to split the data into the intermediate nodes, and it actually affects how a decision tree draw its boundaries, let's say. Okay, so that is nothing but the entropy. And when we talk about information gain, so let's see why does it matters. Okay, so why we need information gain. So it can be considered as a main key that is used by decision tree algorithm to construct a decision tree. Okay, and also decision tree algorithm will always, it will try to maximize the information gain. Why? Because we want a stable we want a stable algorithm, right? We want a good performance from our algorithm. So that is why it will always try to maximize its information gain. Okay, and also an attribute with the highest information gain will get splitted first. Okay, so in our case we can say that this particular node, the root node, is a node that has the highest information gain value, and that is why it is splitted at first. Okay, so this is how the structure is slowly formed in a decision tree. So that's why entropy and information gain plays a vital role as far as decision tree is concerned. So these two things have their own mathematical formula with which we will be able to code our decision tree algorithm. But as far as our assignment is concerned, we will be using scikit-learn library, which has already implemented this algorithm, and so we just have to invoke the library and feed it the data. Okay, so our code is pretty simple, and so you need not to worry about coding it mathematically. Okay, so and also let me tell you, when the entropy is 1, it can be termed as a worst split. Why? Because whenever the entropy is 1, the answer to that particular question asked over this particular node will be having 50-50% chances. I mean, let's say the marital status, the question regarding marital status is asked at this particular node, whether the person is married or not. So the answer to this question will be 50% yes and 50% no. So in that case, our model, it won't be able to give a firm decision on whether the marital status of that person is married or unmarried, because of these 50-50% in both the cases. So this entropy with 1 can be considered as the worst entropy, and the values in entropy lies between 0 and 1 only. Okay, so it can be 0.10, 0.20, 0.40 and so on, okay, till 1. So that's it. That is it for this tutorial, guys, and in next video we will see how to code our decision tree algorithm. Okay.